a virus is very, very, very small. It's about, in scientific terms, 120 nanometers in size across for the COVID virus. If you took the COVID viruses and you added them next to each other to form a chain, you would need 10,000 COVID viruses to equal the same size as a full stop. That also explains why face masks have to be really high grade for you to have a degree of protection against the COVID virus, because the fabric and the folds within the face mask are such that the virus can penetrate through unless it's specially designed or a very, very high grade. And a virus really is comprised of two pieces of chemistry. It has at its core a length of molecules which are all linked together, around about 30,000 of them, and that gives the genetic information from the virus, and it's all mangled up. And the second part of the virus is its outer coating, and that outer coating is really essentially just a layer of grease. The way in which soap works against a virus is it's made up of two parts. It has a long tail, which is really grease loving, and it has a really water attracting part. So when you put soap on your hands, what happens is the soap molecules go into the coating of the virus, and the greasy part of the soap goes to the greasy part of the virus and acts as a molecular crowbar to open the virus up and help to inactivate it. To wash your hands properly, you need to have about 20 seconds with hot water and with soap. The reason for that is that the temperature increases the rate in which the soap works. By rubbing your hands together quite thoroughly and by cleaning each part, you make sure the soap molecules get into all the folds of your skin. So make sure if there is any virus lurking, it will help to remove the virus. And it's also important that you have running water, because that helps to wash the virus away. If you don't have available soap, the next best thing for you is washing up liquid to be able to inactivate the virus. The washing up liquid contains very, very similar molecules to what you have in soap. It consists of this long tail, which can help, of waxy molecules, which can help to break open the virus. If you run out of soap, you can fill your soap dispenser up with about 1/3 to 1/4 of washing up liquid, fill it with water, shake it, and then you can use it. And that will be very effective in pretty much the same way as what you have in normal soap, but it could dry your hands out a little more. Now, after washing up liquid, the next best would be to use your hand sanitizers. Your hand sanitizers contain alcohol, and alcohol has very similar properties to soap molecules. It has a water-loving end, and it also has a tiny little molecular crowbar, a greasy end, which can go into the virus coating and help to split the coating apart. But it tends not to be quite as effective at soap as this, and also you need to have quite a high concentration of alcohol, typically 70% or more. If you're looking at a surface and you're looking to clean your surfaces at home, the gold standard for inactivating the virus is just household bleach. Household bleach contains two components which can really help to disable the virus. Those two components are something called a surfactant, and the surfactant acts in pretty much the same way as the soap molecules do and help to break apart this greasy layer. But also, and this is the key ingredient, a Superman molecule, if you like, is a molecule called sodium hypochlorite. Now, sodium hypochlorite in water can produce chlorine. Think swimming pools. That chlorine can actually get in and interfere with the genetic code of the virus. It can react at a chemical level to help split it apart and inactivate it, or to change some of the chemistry of the virus, which really just kills the virus. If you don't have bleach, then Dettol, or I shouldn't give a trade name here, but you can use an antibacterial surface cleaner, will work. It doesn't work quite as well, but it will work pretty effectively to be able to clean your surfaces. Now, the information that the government has given people about this virus is that we're doing something called social distancing. And that is where you have a 2-meter gap between you and other people. The reason you have a 2 meter gap is that if you cough or you sneeze, which are the main methods for you transmitting the virus, in particular coughs, about 95% is transmitted through coughs and only 5% through sneezes, the virus particles will spread out. Now, often with viruses, and we don't know exactly for COVID, but for most viruses, you need to have a certain critical number of viruses into your body before it triggers the full virus mutation processes and the virus propagation. And so by keeping your distance, if someone does cough, the distance that the viruses have to travel is such that they'll be very, very diluted or even disappeared completely at a 2 meter distance, which is why there is this recommendation.